Now let's talk about sample sizes. At times, you will need to determine the sample size n that can let us estimate a population proportion within a given margin of error. Recall that originally the second part of our confidence interval for proportion P formula is z star times the square root of p hat times 1 minus p hat all over n, and that's all inside the radical. This section of the formula was representing the margin of error in the confidence interval. To determine a sample size n for a C% confidence interval of a population proportion, the margin of error, or ME, will be a maximum of this section of the formula, that's z star times the square root of p hat times 1 minus p hat all over n, where p hat is a guessed value. A cautious but effective guess is to use p hat being equal to 1/2 or 5/10, because the margin of error is largest at that value. Let's try an example where we are finding the sample size. A senior and a junior are running for student council president. We want to estimate the proportion of students in the school who plan to vote for the senior candidate with 98% confidence and a margin of error no greater than 3%. How large of a random sample do we need? The first step to solve this example is to use the sample proportion of 5/10 or 1/2 and the appropriate z star value based on the confidence level C. So we have that p hat is that 1/2 or 0.5 or 5/10, and because of the confidence level that we need, the z value is 2 33/100. Next, set up the margin of error to be less than or equal to 3%, or 3/100. So that section of our formula that we're working with, z star times the square root of p hat times 1 minus p hat all over n, has to be less than or equal to 3/100, which is equivalent to 3%. So we substitute the z value in that we found. We know that p hat is 1/2 or 5/10, so we put that into our formula and put it over n. And now we're going to solve for n. So I'm going to show an extra step in here. I'm going to rewrite this problem as 2 33/100 times the square root of 5/10 times 1 minus 5/10 all over the square root of n, because remember, the square root of a fraction is equal to the square root of the numerator over the square root of the denominator, and that's less than or equal to 3/100 or 3% written as a decimal. And then if we cross multiply, this square root of n is going to go to the right side of our inequality. So we'll have 2 33/100 times the square root of 1/2 times 1 minus 1/2, and that's less than or equal to 3/100 times the square root of n. And now if we divide both sides by 3/100, we'll end up having this formula. The 3/100 will go beneath the 2 33/100 times the square root of 5/10 times 1 minus 5/10, and that's less than or equal to the square root of n. And the last step here is to solve for n. And since n is underneath of the square root, we have to square both sides of this inequality. And now remember, we have to distribute the square to both terms that are being multiplied in here. And the squaring undoes the square root, but then we're going to have 2 33/100 divided by 3/100 quantity squared. So this is what we have to find our n value. If we actually put this formula into our calculator, we end up getting 1,508 and about 28 thousandths if we round to the nearest thousandths place. Therefore, a sample size of at least 1,508 voters needs to be used for 98% confidence with a margin of error less than 3%. Now, some of you may be asking, well, our n value had a decimal. Shouldn't we always round up? Well, usually, if it's a significant amount, you would. But let's actually double check in the calculator. If we substitute 1,508 into our formula without the inequality section, are we going to get 3% as a value? So if we do substitute it in there, we do end up getting 3%, and the decimal values afterwards are so small that it doesn't change it to be greater than 3%. So in this case, we can absolutely round down to 1,508 voters.